Hey, I'm Dave. Welcome to my shop. Today in Dave's Garage, we're going to build the atomic fire lamp from start to finish. Longtime viewers of the channel may be used to seeing it up over my shoulder where it's been a long-time fixture in my shop. Long story short, the lamp begins its life as a hanging lamp that I purchased from eBay. I then modify the lamp to turn it into a freestanding lamp, rip out the simple white LEDs that it comes with for illumination, and then replace it all with more than 200 individually controlled 24-bit color LEDs connected to an ESP32 microcontroller. Now feel free to tune out for a second as I casually tell you that the ESP32 features a dual-core 240 MHz processor along with a 12-bit DAC that I use to sample the digital audio from the room mic, run it through an FFT to create a spectrum analyzer, and then do beat detection. Which is all a fancy way of saying that the pretty lights can follow the music and react to it. I had planned to both build and program the lamp in a single episode, but there was no way I could do both well and fit it all into a single episode, so I've opted to split the project into two segments. This build episode of the lamp itself, and then a second programming episode that will feature the software I write to control the lamp. Odds are you'll feel a lot more comfortable with one than the other, but I hope you enjoy both segments. Please make sure you subscribe to the channel so you don't miss the follow-up episode. One change I made from the original is that for the first incarnation I made the lamp tall by adding a mast in the middle. For this version I took more of a short squat snowman approach, and I like it better if for no other reason than it's a lot more stable. One of my sons is an aspiring music producer and I wanted to build him a copy of the lamp for his home studio, so I ordered the hanging lamp from eBay and then waited for it to arrive from China via California. The box is finally here, so let's dive right in and get busy with the construction. Alright, let's open the box and see what we've got. Always close the knife. Aw, how thoughtful. A little greeting card and some instructions. We won't be using those. I don't know what this is. Oh, specifications, handy. Now, this is what looks like a laughable stamped wrench, but I don't really have anything with that exact angle on it, so I'll hang on to that. This transformer seems to take line current in and put out 48 to 96 volts AC out. Weird. Not something I can make use of in my project. These are the arms of the atomic lamp, and each will have white LEDs installed in it from the factory. Now, this is actually a hanging lamp, but we're going to mount it upside down, so this ball, which was the bottom part, will now become the top part, and this piece that used to screw to the ceiling will now become the base. Our first task will be to remove the white LEDs from each of the arms so that we can replace them with the addressable colored LEDs. First, we remove the rubberized diffuser, which reveals the LED strip. Then we need to get some kind of tool underneath that and just pry it out and rip it off. Our addressable lights need 3 wires, not 2, so there's really not much point in saving the existing wiring harness. These factory strips are glued in something fierce, but we'll get them out. I'm going to try prying this one out from the center, see if that goes any better. I don't think there's any way I'm going to be able to reuse this transformer because the voltages are too high and the wiring is just too fine for the amount of amperage I need to carry at 5 volts. So we're going to strip it out. As much as I hate to cut it, there's just no way I'm going to fish that through there, so cut it is. I'd like to fish my own wires through here, so I need to take this all apart and figure out how much clearance I have and so forth. After all this fighting with the cable, I later changed my mind and decided to run just power and ground, so I ran a simple red and black pair of 22 or 16 gauge up through here. Just quickly mocking up the assembly here so that I can see how the wire goes up through the base, up through the actual shaft, and then comes out and turns around inside. And here's where the goofy little wrench comes in handy. I could use a crow's foot on this, but hey, they give me the wrench, so I'll use it. These adjustments here will offset how far up or down the top of the ball sits and allows you to get a good fit. Once we get the 4 arms on, we'll be able to do a full mock-up of the assembly. And now there's no wiring or anything, but the first time through a build like this, you pretty much have to do it just to see how everything clears and where it all fits and whatnot. If you were building it the original factory way as a hanging lamp, you wouldn't have that issue, but as the first time through as a standing lamp, we got to make sure it all works before we take our time to insert a bunch of wiring that has to be ripped out because we find that later it doesn't fit. This would be tougher without this wonderful little goofy wrench. And here's my hanging lamp converted to standing. One problem with this lamp is that you have enough torque when you're turning the arms, if you choose to monkey around with them, that you can easily screw and unscrew and retighten and loosen the arms. And so what I'm going to do is I'm going to seal them up with some Loctite green, which is the next strongest relative to Loctite red. I will also use some red on the outer ones that are unlikely to ever need to come apart. Unlike the thicker Loctite red, Loctite green has strong wicking action which will cause it to flow into any crevices or threads or cavities that it encounters. Now, when I have a repeated action like these 4 arms, I will show you most of the steps, but I will, of course, edit it down so you're just seeing a few seconds of the repeats, just enough so you know what's going on and don't get lost. Well, this connection now features a nut, a lock washer, and Loctite red, so it should not pivot a great deal if I'm lucky. If I need to take this apart, I'll need to remove the arm out of the Loctite green connection. And I want to make sure I've got the arms in a visually appealing arrangement because they're probably going to set up pretty tight once they're set. And with all the physical build issues out of the way, we can now proceed to wiring it. I've had good luck with my lighting strips from BTF Lighting over the years, so that's what I'm sticking with for this project. I have unfortunately had to go with the black PCB because I could not find a lighter color PCB in stock, but it turns out not to matter once it's installed anyway. These strips are the highest density I've found, 144 pixels per meter. We're going to cut them down to approximately 53 per arm. Off camera, I ran off and I smoothed off with a grinder this one little intersection here between the tube and the arm so that it does not act as a pinch point or cutting action point for the wiring. It still pains me to cut the ends off of these, but we want to feed the wiring in from underneath so that it can be pretty much flush to the end. If I had to turn the wiring around 180 degrees at the very end, it would leave a big gap at the end. I'm pretty fortunate that the strip is probably 1 centimeter is how it worked out, but an exact fit for the channel that runs through the arm. These are my Nipex wire strippers. They're not a sponsor, but they really should be because they make some awesome tools and then I could have some free stuff. But for now, you can buy a pair just like I did, and I'll put a link in the description. And they are totally worth it. The The adhesive strip will serve the important function of insulating the contact pads that would otherwise be visible on the back of the strip all the way along from the metal channel. Unfortunately, I had to remove the backing on the very end to solder to it, so as you see later, I will use hot glue in order to insulate it. Now, I still don't like this right turn, even though I have taken the extra steps of using heavier gauge wire, lower voltage transformer, and I've ground down the channel to smooth it out, so it's in many ways better than the factory one. But I still kind of don't like it. But hey, if it was good enough for Shenzhen, it's good enough for me. Now, where the wiring would be otherwise exposed because I had to remove the backing in order to solder to it, I'm going to inject hot glue, which will serve both to retain it physically, hold it in one spot, and insulate the contact pads from the metal channel. Each arm has a data, a power, and a ground. The data, which is green, is completely independent and does not cascade from one arm to the next. It is a separate independent channel for each arm. I've taken a number of precautions to avoid a short circuit, but I want to make sure that in the end I didn't create any. So I'm going to check that there is no continuity between any of the wires and ground and any of the wires and each other. And there you go. But have I really covered all the possibilities? Let me know in the comments. If you think there's a scenario that I did not hit there, let me know precisely what it was. We can put the rubber diffuser back in now, and it should clear everywhere really nicely except right at the very end where we've got the wiring connection. It's a little thicker there because of the glue and so on, so it might have trouble, but it'll be hidden by the end cap anyway. And with that, it's on to the next arm. I still measure each one individually, even though I know darn well that the arms are probably identical length. I still custom fit each one. When cutting these, you want to use flush cut pliers, not angle cut pliers, and you want to cut it in such a way that you leave whichever pads exposed in the direction that you might have to solder to them. Since I'm not soldering to the end here, I clip flush up against the last LED, leaving the pads on the remainder of the strip in case I need to solder that at some future point. Next, I'll mock up approximately how much wire I need by running it through the arm, about the length of the tube, and then enough spare to be sure. This is 4-wire connector, but of course I only need red, green, and black, so I strip the blue and toss it. If I were cascading data from one arm to the next or something like that, then I would use the blue as the data return path. Here's a close-up view of the strip. As you can see, the 5-volt data and ground are pretty clearly marked. I don't know if it's universal, but there also seems to be a little resistor on the power side. As I prep each strip, you can see how I fold back and then trim off a little bit of the adhesive strip in order to expose enough of the contact pads to solder to. Keeping in mind that I am in fact a software guy and not a hardware guy, I've had pretty good luck soldering these. If you get some solder on the wire, tin that up, get some solder on the pad, heat them up, stick them together, and hold them in place with a tool. That's kind of the only secret I've come up with. How beautiful my life will be with you. Indeed. And finally, I proceed with arms 3 and 4. And there we have all 4 arms fully lit and wired and reinstalled and set up. Our next task is to strip the wiring here so that we can connect it up to the ESP32 circuit board. The wiring is basic enough here that I didn't even do a schematic. What I'm basically doing is tying all the grounds together, all the powers together, and then connecting the 4 data lines to the chip. This is my DeWalt heat gun, which is a little slower than a plug-in heat gun I find, but it's faster when you take into consideration you don't have to drag it out and plug it in and all that. Now, are you getting the sense that I really like these wire strippers? Because I really, really do. You might notice I'm using my Nipex cutters on the wiring, which is actually completely the wrong thing to do. I've just kind of gotten away with it in the past because they seem to be incredibly tough. But I have damaged cheaper cutters in the past by cutting metal with them because they're really intended to flush cut plastics and so on as opposed to metal. So don't do like I'm doing. And into that bundle of power and ground, I inserted a small white and a small red, which will wind up powering the circuit board. And so the only connections to the circuit board are power, ground, and then the 4 data wires. Hardly a work of art, but it should be functional enough for my purposes. And as a quick spoke test, I'm just going to compile and link a little test app and then upload it to the chip and make sure I get some light. And this is where I made the big mistake of forgetting to plug in the bus power. That black connector there that has nothing plugged into it. That means all the power was coming from the USB and through the regulator on the chip, and out comes the smoke. And one quick circuit board replacement later, and everything was happy. Next, I connected the microphone to make sure that it was working. Doot, 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 doot. And finally, the remote control, which allows me to change colors and effects. A quick test of a multicolor flame effect, and we can confirm that everything seems to be working properly. We can now turn our attention to the software and getting it ready. Thanks for hanging in there with me. You have no idea how much stuff I had to cut out to get it down to that length of time, which was indeed not short. The next time we visit the lamp here in Dave's Garage will be to write the software to run the effects, including responding to the music. I'll also give you a complete demo of the very best effects, so please be sure you're subscribed to the channel and that you turn on the bell icon so that you're actually notified of the follow-up episodes. Thanks for joining me out here in the shop today. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage.
This little chair will be waiting for one of you, and a rocking chair for another who likes to rock, and a big armchair for two more to curl up in. All next time on Dave's Garage.